All right, how's everybody today? Good, good, good. Okay. Just a couple things. We should be able to finish up the current lesson today, and then I'll go ahead and give you some time in class to go ahead and work on your assignment. We are going to be able to start probability. Oh, thank you, Jacob. Okay. We are going to be able to start probability tomorrow, and that'll most likely last the rest of the week, and then we'll continue that next week with conditional probability. There are a few things happening at the end of this week, and then next week, Friday during this class, we have a fire drill, so that's going to eat up some of our time, but we'll just take some extra. I mean, we are a little ahead. What's that? I'm sorry, what? Oh. Hey, as long as if you're not learning math, you're learning humor. I mean, something. I'm a positive role model. What was I saying? Oh, yes, we got a fire drill on Friday during this class. Next week we got the PSAT, but according to the schedule, it's going to be a half day, so if you're not taking the PSAT, you don't have to bother coming in the morning. There won't be classes, but in the afternoon, it is a B-day schedule according to what I've seen. So I will be able to see you Wednesday afternoon. And the big item, though, is on Monday. That's our what? That's our test. Okay, so look for it to have your sets, everything about those, the complement, intersection, union, logic and truth tables are going to be on there, implication, equivalence. So we want to know about all of those behaviors. We're going to go ahead and get our focus activity done. Then, like I said, we'll finish up the assignment, or excuse me, the lesson. Then I'll give you time to work on the assignment. That's going to be due, I believe I said on Thursday, correct? Yeah, so we're going to have that due on Thursday. And then we'll just go from there. Any questions about what's coming up? Hey. It's got to be 1 something. I don't know for sure. I know that all testing has to be done by noon, so that they go ahead and get them boxed and shipped off to College Board so they can get those graded. And then, of course, we have to have lunch. So I'm guessing it's going to be, if not 1, then after. I think normally when they do an afternoon start, isn't it like 1:35? Somewhere around there. I'll find out for sure as soon as I can. I'll let you know. Okay. All right, well, let's take a look at our focus activity here. We are turning these in on Friday. It's one of the things we're going to do at the end of the week. And hopefully, who is our student teacher? Mr. Yacht, okay. Mr. Yacht's going to be able to work that with you. It depends on if he has the time to go ahead and look it over. He did state that statistics was not one of his strong suits, but eventually we're going to go ahead and get him interacting with you guys. So this is number 3. You'll get the 4th one on Thursday. We'll turn those in on Friday. So let's take a look at what this guy says. The table below shows the price of petrol and the number of customers per hour for 16 petrol stations. So there's quite a bit of data here. It's just it wasn't long enough width-wise, so this is one set of data. You notice the rows, the top and the bottom are the same. Okay, so the first thing we want to do is calculate R for the data. Okay, Pearson's correlation coefficient. So I'm going to come on over here. I got my calculator. Thank you, Jacob. Okay, so where do I need to go if I wanted to input data like this? What's that? Lists and spreadsheets. Okay, so I'm going to choose new document. Oh, thank you, man. Okay. Okay, so lists and spreadsheets. Okay. And again, you can go ahead and title your columns, in this case, petrol, number of liters cents, I believe, and the number of customers. I'm just going to go ahead and put X and Y. Remember, avoid the equals row. And then now we just have to kind of bear with me for a minute because this is where we get to put in all 16 of these values. So 106.9, okay, 109.9. 104.5, 104.9, okay, 111.9, 110.5, 112.9, halfway there, well, a quarter of the way there because we got to go through the second row as well. 107.5, 108, don't need to put in the 0.0, 104.9, 102.9, okay, then we got 110.9, 106.9, 105.5, and our 16th one, 109.5. Okay, so there's my first row for the first column here, Control 7. Halfway done. And here we go. Here's the number of customers. 45, 42. This will go a little faster. 25, 48, 43, 15, 19, 10. We should be halfway through. Okay, so 30, 23, 42, 50, 12, 24, 32, and finally 17. Okay. All right, so it took a minute, but we did get all of the data into the calculator. All right, and what do I do now? Menu, statistics, stat calculations, two variable. We are comparing two different sets, okay, the cents per liter of the gas, and we're also talking about number of customers. So two variable statistics. That's what I want to go ahead and make sure is here in the X list and the Y list. So that's X. Okay, then the Y list right there. Okay, disregard the frequency list. This is not a frequency table. Looks like everything's going to show up in column C. I'm going to click OK. And it looks like right here, I come across my value of R pretty quick. So let's say negative 0.924. Let's go ahead and round that to 3 sig figs. Okay, so let me get this right here. So about negative 0.924. Okay. So it says describe the relationship between the petrol price and the number of customers. Okay. So we definitely want to go ahead and put this in a complete sentence. I'm probably not going to worry about that right here, but what are two words that would be very good to describe this? Okay, strong and negative. There we go. I'd say there's a strong negative. Okay, relationship between the petrol price and the number of customers. All right, so you can just go ahead and take that question, basically the statement that's asking you what to do, rewrite it into your sentence. I'm just going to go ahead and put strong negative. Okay, we know definitely it's strong because it's very close to a negative what? Negative 1. Okay, very close to almost a perfect correlation. Couldn't think of the word for a second. Okay, C, use technology to go ahead and find the line of best fit. So this is my y equals mx plus b equation, my line of best fit, my prediction equation, my regression line, a lot of different ways to describe it. So where would I go from here? Okay, so I'm going to go home. Which one do I choose? Data and statistics. It's this one right here. Looks like a histogram. Okay. This is the one time that all of our screens are going to look different. It just plots the points randomly. So I use tab. Always take care of the horizontal first. There's the X's, and then tab, there's the Y's. Okay, so there's the scatter plot. Okay, kind of looks like what I would expect. It falls to the right. The lines are very close to the points are very close to a line I would draw. So how do I get it to show me the line and the equation? Menu, analyze, regression, mx plus b. There we go. Okay. So why don't we go ahead and write this in 3 sig figs? So negative 4 point. Oh, is that one out? I hit it 2 years ago. And I've still got it. Yes. Actually, that's nothing to sneeze at. Okay. That's very true. Even at the beginning of the school year, you know, when the lists go home for elementary and they say they need certain supplies, and each of them now needed 3 boxes of tissues, I was like, that's easy. I just brought tissue home. It was awesome. Okay, so let's go ahead and round this, or not round it, but write it in 3 sig figs. So I would say negative 4 point what? Okay, 27x, but then plus what? I just say 489. Okay. So I'm going to go ahead and write this out. I'm not going to do it with the mouse. Negative 4.27. Negative 4.27x plus, what was it, 489? Okay. Now, the next part of this thing, you'll notice I've got it covered with a shade here because I want to give you the opportunity to think about it. It says interpret the gradient of this line. Now, remember, gradient, we're going to talk about this more later in future lessons, but that's just another word for what? Yeah, gradient just means slope. Okay, it's your rise over run. So we're talking about this guy right here, the negative 4.27. What would that mean in the real world? Think about it. What do the x's represent? It's the price. It's the number of cents per liter. Okay, so when I plug that in, what does this function give me? What's the y value? The number of customers. Okay, so what would that negative 4.27 be in the real world? What happens as the cost of the gasoline increases? Fewer people. There we go. That's exactly right. Because it's negative. So the gas station is actually what? The more they increase the price. They're losing customers. Okay, so that's basically what I put here. For every 1 cent per liter increase in the price, the station will lose 4.27 customers. Now, of course, you can't have 0.27 of a person. This is just the function that was determined based on the data. Okay, so I'd say you're losing at least 4 customers for every 1 cent increase. Because that makes sense. If you go ahead and plug in, like in this case, if you just go ahead and plug in a specific value like 106.0, and then plug in 107.0, the first time you lost negative 4.27, the very next cent you're losing double that. Okay. So that's just kind of how I wrote it out. Remember, is there only one way to do that? No, there's going to be a lot of different ways you can get your point across. We've talked about that before. Okay. In fact, for E, it says estimate the number of customers per hour for a petrol station which sells petrol at 115.9 cents per liter. So now they're giving you a value of X. X is equal to 115.9 cents per liter. Okay. So I'm just going to plug that into my equation, and can somebody help me out with that? What should I be getting? Okay. I got negative 5.89. Is that what you guys are getting? Okay. Well, there's already a couple of things wrong with this, because the last part, F, says comment on the validity of your estimate from part E. Okay, well, the first thing we notice, remember, Y represents the number of what? The number of customers. Well, we got a negative number. Can you have a negative number of customers? What'd you say? If you boycott it, sure. What did this gas station do? It went out of business? Well, I mean, it could have gone out of business because of the boycott, but why did they boycott it in the first place? Because of the price. Maybe the prices got too high. Okay, but realistically, you're not going to have a negative number of people. Okay, that doesn't make sense the way we view things. But also, did anybody kind of focus in on this one right here, the 115.9? There you go. It's outside of your data set. Remember, do we like to predict outside of our data set? What do we call that? Extrapolation. There we go. So I kind of just wrote that into my statement here. So if you have your own version, I said my estimate would not be reliable because it is not possible to have a negative number of customers. And then I also put an extrapolation. I could have probably made that into a better sentence, but I had to go to a meeting during lunch and I only had a few minutes, so I did it quickly. Okay. All right. Any questions?
Each question builds upon the previous.
Uh-huh. You'll see that a lot.
Do that?
Yes.
Will they be multiple choice or open-ended?
They are not multiple choice. They're open-ended. So especially, and it depends on the individual. You know, paper 1 is going to have 15 questions, and you're given 90 minutes. Okay. Paper 2 is going to be 90 minutes, but you're going to have 6 questions. So personally, if I were looking at which one I think is going to be more difficult, I'm probably going to say paper 2, simply because one problem can contain statistics, probability, and it could throw in any other number of concepts that we've talked about. And you're right, they are progressive. And that's kind of what makes it dangerous, because if you happen to get a problem or an answer wrong in the beginning, that can what? That will go through your other answers. The good news is they have what's called error carried forward. Does anybody know what that means? Yeah, there you go. In fact, the closer we get to those tests, I'm going to go ahead and release what's called mark schemes. This is what the IB graders have to follow when they sit down and grade these. In fact, for these problems, you're always going to have in the probably in the bottom right. Okay, we can go ahead and do this. Or, well, imagine there's a bottom right over here. There's going to be some little section that has blanks with all your little parts here. The grader is immediately going to go ahead and look at those. If your answer is correct, they won't even look at your work.
Teachers, please pardon this interruption. The Lomax bus has just arrived. Please excuse any students coming from the Lomax. Thank you.
Okay. They're not going to even go ahead and look at your work. The only time these folks are going to look at your work is if your answer is wrong. Because in that case, maybe you had the wrong strategy or maybe you made a mistake, but if your mathematics support the answer you got, you can still get credit for that. Okay, so that's definitely a good thing. So that's why I always encourage people, no matter what, even if it's like one of those gimme answers where it only has a mark of 1, at least write something down, because if there's nothing there, they won't be able to give you credit on that. Okay, so that's really good, yeah. They are progressive. All right, any other questions on the focus activity? All right. Well, good. Let's go ahead and put that to the side. Okay, we're going to be turning those in on Friday. We will have 4 by then. We'll get the 4th one on Thursday. Okay, let's go ahead and finish up with implication and equivalence. All right. Okay, so we were looking at implication, if P implies Q, all these different ways to look at it. We've been talking since last week about the behavior of implication. Let me go ahead and get down here very quickly. Went too far. All right, here's the behavior of the truth table. If P, then Q. The only one you got to be careful of is what? True, false. Now remember, order matters. It has to be true first, false second. That's the only one that ends up in a false statement. The rest of these, true, false, false, they're all true. Okay. And then we went through several examples. We talked about the implication, the if P, then Q. Then we had the converse, which does what? The converse simply switches the two propositions. What does the inverse do? The inverse negates them, doesn't switch them, but it negates them. And then the contrapositive does what? Both switches and negates. Okay. And then we started talking about equivalence here. This is the behavior that we're going to notice for equivalence. This is the if and only if. Okay. Now remember, this right here, it has the double arrow. You're only going to get a true statement out of this if the implication in both directions is true. Only if P implies Q and if Q implies P is true. That's why for this one, we had those additional columns to go ahead and show the implication. So we had a true, which gave me a true, which only gave me another true, even though originally those were false. Okay, and I think we got this one. So it looks like we got through a tautology. What was a tautology? Yeah, that means your final column of your truth table is nothing but truths. That means that what you were testing, that is a valid logical statement. Okay, that's a tautology. Now, if you have a tautology, you can have what's called a contradiction. This is a compound proposition that's always false. There you go. So if your final column is nothing but truths, that is a valid logical statement. It's called a tautology. Now, if your final column is nothing but false, all the way down, that's what we call a contradiction. That is not a reasonable or logical statement. All right. So it says use a truth table to show that the compound proposition P, what's this? And, okay, the intersection. And what's that sideways L? There we go. So P and not P, okay, is a contradiction. Well, if the proposition P is true, false, what's the negation? This is false, true. Okay. So what does the intersection mean again? Both have to be true at the same time. That's the only way I'm going to get a true statement. All right. So true, false, that's a false. False, true, that's a false. Okay. So if your final column ends up nothing but falses, that's what we call a contradiction. Okay. Construct a truth table to show all the truth value of the compound proposition. So we have not P or Q implies R. Okay. Now let me ask you, why do we have 8 rows here? Remember, what base do I use when I'm trying to figure that out? Okay, we use base 2, and you always raise it to the number of propositions you have. So we have P, Q, and R. Okay. So if I'm going to go ahead and fill this out, the first thing I'm going to do for that first column, the first half is all going to be what? True. So true, 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 true. And then false, 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 false. Now, how am I going to go ahead and write out the second column, Q? Oh, not yet. Not true, false, true, false. True, true, false, false. I'm going to take half of the original one. So I went 4 here. Well, now I'm going to go 2 here. So this is true, true, false, false, true, true, false, false. And then now for this third one, what do I do? True, false, true, false. Again, I'm taking half the number of rows that I did from the previous one. So true, false, true, false, true, false, true, false, and we're done. Okay. So you remember when I'm talking about these truth tables, again, they're progressive as well. They go ahead and start with each of the individual propositions, and then they start to build. We want a column for the negation. We want a column for this union. And then the final column is always the statement that you're testing. Okay. So what am I going to put for not P? Just the opposite of what you had here. So false, 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 and then true, 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 true. There we go. Okay, so now the next column I have not P or Q. Is this inclusive or exclusive? This is inclusive. Okay. Inclusive. So there is no bar. Exclusive has the bar below it. So what does that mean? One or the other or both. The exclusive, if it has the bar, that does not allow both. Okay, so I'm wanting to take not P or Q. Okay, so one or the other or both. So true, false. Okay, now the true, false is true. What about false, false? False. Okay, false, false. True, true. True, true. False, true. False, true. So it looks like only my third and fourth rows are going to be false. Would you guys agree? Okay. Now let's do the implication. So this one implying R. Remember, order does matter. So I'm going from here to here. I have to be looking in this direction. I've got to go from this fifth column to the third one. You guys want to try to fill this out on your own and then we'll come back together? Or do you want somebody to come up here? What would you like? Try it on your own? Okay. Let me give you a few seconds to take a look at that. Doo-doo-doo. Oh, and Ethan, you grabbed a focus activity when you walked in, right, sir? Okay. Okay, now let me go ahead and come back and see if I can catch up to you folks. What I might do, instead of going row by row, I might look for the only one that I have to be careful of. Remember, with implication, the only false statement is what? It has to be true and then false. But remember the direction we're going. We want to go from this union implying R. So the only one I need is to go true, false, backwards. So what row do I start with? Okay, so I have a true, false, so that's got to be a false. Okay, anything else? Let's see, I got a true, true here. And right after that, I have another true, false. So that's a false. Okay, then I have true, true, and another true, false. Is everybody okay? Did I make a mistake? true, false, true, false, true, false. So the rest of these should be true. True, 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 true. Okay. So can I actually go ahead and say that this is either a tautology or a contradiction? No. That means there would be aspects of it that are true, but there are aspects that are false. That wouldn't be logically sound. Especially if you're looking at sets, okay, with elements, okay, that's a more definitive way of looking at it. Okay. How many people got that right? Okay. Ooh, not a lot of hands going up. Can I do anything to help? Hey.
I'm so confused on why false true is true and not false.
Oh, true, false?
No. What?
Oh, it has to be true, false.
Yeah, so I know it has to be true false, but why is it that false true is still true?
Well, what was the example that we did in class? It was if your pet is a dog, then your pet is a mammal. And I think the one that that was the false true was the cat. Because if your pet is a cat, then it's still a mammal. It's not a dog, which negates the first one, which makes it false, but it is still a mammal, which was true. So the false true is still a true statement compared to that original statement we were talking about.
But how would you know, so like in this situation, if it was just those, how would you know that it wasn't?
Oh, like if we don't know what this is comparing? Oh, just because of the behavior.
Okay.
From the behavior at the very beginning, yes. So if I come back over here, no, that wasn't it. This guy right here. Okay. Now, you definitely want to go ahead and be familiar with it. You want to be comfortable with it. But I have noticed in years past on the formula booklet, you are going to be provided a formula booklet during, I can't say the word booklet, during those paper exams. They have provided in the past couple of years truth tables with those behaviors filled out. Okay.
So you just know that true false is the only one.
True false is the only one that's false when we're talking about implication. Okay. All right. Okay. Let's talk about fuzzy wuzzy. Testing the validity of simple arguments using truth tables. Okay, use a truth table to show that the following argument is always true. Okay. Well, if this is always true, what should I be getting here in the last column? Yeah, just true, 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 true. It should be a tautology. Okay, so let's see what we got here. If fuzzy is a bear, then fuzzy is a mammal. Okay, well, fuzzy is a bear. Therefore, fuzzy is a mammal. Here are my propositions. Okay, fuzzy is a bear, that's P. Fuzzy is a mammal, that's Q. We're going to go ahead and write this symbolically. Now, a lot of this you're going to be able to pick up on pretty quick. How do we know that there's an implication at the beginning? It says if and what? If then. Okay, so there's my if-then statement. So that tells me I'm going to have my implication. But it also provides me another bit of information. So think about how you would say it. I know this information and this. Okay. So I know this implication and this statement. Well, therefore, that's another form of implication. I can say fuzzy is a mammal. Okay. What we want to go ahead and do is take our sentences and rewrite them using these symbols so that we can test the validity of it. We can actually find out, well, is this true or is it false? Okay, does that make sense? Anybody have questions? Okay. Even if not, just kind of bear with me for a minute. Because fuzzy's a bear. There you go. Takes a little practice. Okay, so you'll notice here is my statement. Okay, the logical statement that I'm testing. You'll notice that's the very last column, so it's progressive. We only have the two propositions, P and Q. So we have the implication, we have the intersection of the implication and P, okay, and then we have just Q again by itself, which is, don't know why that's there, actually.
It's so that way you can look at it more easily. So
I guess so. That's probably something that that's probably something I wouldn't have thought about adding into the truth table because I already had this. But yeah, if it helps you so you don't have to, like on the previous one, go backwards, definitely go ahead and put it in there again. So let me go ahead and start with that one. True, false, true, false. Okay. Do you guys want to try this one on your own or do you want to work it together? How about we work this one together and the next one we'll try on our own? Okay. So implication. Okay. So I want to show that P implies Q. So order matters. So Ella, what's the only case we got to be careful of? The true false. So true false is the only one that's false. The other three should be true. Okay. So now I want to go ahead and compare this implication to P. But what's the intersection again? It's one and the other. They both have to be true at the same time, right? Jacob. It says when convenient, so we can go ahead and finish up. Okay. So let's see here. I'm going to be comparing these. Now, order doesn't matter with a union or an intersection. Okay, so true, true. That's a true. What about true, false? That's a false. False, true. False. And false, true. That's another false. Now, we already filled in Q. Okay, so I want to show that this group right here implies this one. Okay. Well, let's think about it. The only one we have to be careful of is the what? It has to be true first and then false second. Well, true, true, false, 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 true, false, false. All of these are what? All of these are true. Okay. So there you go. Is what we said here, if Fuzzy is a bear, then Fuzzy is a mammal. Fuzzy is a bear. Therefore, Fuzzy is a mammal. According to this, would that be a logically sound statement? Yes. Okay. There we go. Questions? All right. Well, let's try another one. Okay. Let's do the same thing here, but for Julia. Okay. Express the following argument symbolically. Use truth tables to determine whether or not the argument is valid. Okay, so at the end, we're going to circle yes or no depending on what we have here. So it says, if Julia is sick, she will not go to work. Julia is not sick. Therefore, Julia will go to work. Okay, so my first proposition is that Julia is sick. Okay, the second one, the consequent, is that Julia will go to work. So why don't we go ahead and do this in a couple of parts. Try it symbolically first. Think about what we did on the previous example. Yes, sir. Oh, I thought you were raising your hand. I was like, okay, that's right. And maybe one thing that can help you out, if you go ahead and start placing your symbols and P and Q above the sentences, maybe that can kind of help you order what you need to do here. Like in this case, if Julia is sick, she will not go to work. Well, here's P, here's Q. Well, what have you done to Q? She negated it. Okay. All right. Now, it doesn't actually say then, but is this an implication? Yeah. Okay, so we know if this, then that. So see, that already kind of gives us an idea what the first part of the logical symbol notation should be. Oh, man. I was hoping to have a little more time to work on the assignment. I'll tell you what, I'll give you some time tomorrow in class. We'll go ahead and start some probability, but then I'll give you some time, because I promised you some time. I want to make sure I do that. Okay. So does anybody want to come on up and write what they believe it to be? Okay. Does anybody just want to tell me, or should I just write it out and we'll talk about it? Okay. I'd say that's good. Okay. Sure. Do you want him to do the truth table too? Like He said no. Okay, so we're given the implication and the fact that Julia is not sick. Okay, therefore Julia will go to work. Okay, what do you guys think? I said that's good. In fact, this right here should be what goes in this last part. So I'm going to go ahead and say P implies not Q and not P. Okay, therefore Julia's going to work. In fact, you probably could have also, checked part of it yourself as you're going through, because you'll notice they had the implication, they had the negation, they had the intersection. Okay. All right. So is there anybody who wants to come on up and show me the truth table? Okay. What time is that fire drill on Friday? What was that? John Henry? Okay. John Henry? You were the first one to answer, right? Completely unrelated, but since you spoke up, why not? All right. See, I can't use that too often because then when I legitimately ask a question, people won't answer. You're not fooling me. All right. True, true, false, false. True, false, true, false. Okay. So the negation of Q, false, true, false, true. Now we want to show the implication. P implies not Q.
Okay, so we only have one true false.
Okay. Well, now remember, order matters. So you're going from P to not Q.
Oh yeah, so it'd be the other one. So the false true is not good, right?
Okay.
False true.
So true, true is okay. False true is okay.
Okay.
False true is okay.
So almost true false. Okay, yeah, I have that.
It just can't be
True false.
true false. Where's the only true false that I have?
Right there. There we go.
Okay.
I found it.
So what should the other ones be?
We are professionals.
There we go.
Okay.
That's a true, 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 right?
Yeah.
Okay.
That's
And then not P. So false, false, true, true.
true.
Now I want to take the intersection of those two. So remember the intersection, they both what?
It has to be both.
They both have to be true.
Okay. Wait, if they're both false, then that's false.
That means it's false. What if only one is true?
Then it's false.
That's still false.
That's both.
True, true.
True.
And then we have Q again. True, false, true, false. And then here's the big one. The intersection implying Q.
Okay. False true is false. Right?
False, true?
False.
True, there you go. So that's true.
False. False.
False, false is true.
True. True. It's true, but true. False is false.
There you
Is the
go.
argument valid? No, because there's.
There you go. Now, it would only be valid if it was a tautology, if they were all true. Okay. Now, it seems to make sense, though, but kind of think about it in the broader sense. Okay. It says, if Julia is sick, she will not go to work. Okay. Well, could there potentially be any other reason why she may not go to work other than illness?
Yeah.
And that's what this is referring to. Okay. I mean, the majority of it, it makes sense, but it's not 100%. Because the only reason she will not go to work is not just due to illness. Is everybody okay with that? Cool. Okay. So like I said, tomorrow I promise, give you time in class to go ahead and work on your assignment. It's due on Thursday, and we have our test Monday. We'll start probability. I can't think of anything else unless anybody has a question.
Besides the drill, is there anything important happening on Friday?
No, the only thing I know of on Friday is just the notes, focus activities. Next week is going to be the PSAT. I know that some juniors are taking it. Any juniors in here taking it? Okay, so a few. Okay. That's it. No, normal week.